This is January 2015, paper 2, and this is question number 8. A pulsar is a type of star. We receive radiation from a pulsar in regular short bursts called pulses. That's why it's called a pulsar. Some pulsars emit radio waves, others emit X-rays. What is the property that is the same for radio waves and X-rays? Well, we only need to mention one, but there are a few we could mention. We could say that the speed is all the same. They all move at the speed of light because they're all EM waves. They're also, if you're an EM wave, they're all transverse. The speed of light is 3 times 10 to the 8 meters per second. Always really good to remember that. State two properties of waves that are different for radio waves and X-rays. Well, they sit at different ends of the spectrum. So you've got radio waves down here, and you've got X-rays up here. Now next to X-rays is the gamma rays, but then if you go this way, you increase the wavelength. If you go in this way, you increase the frequency. So what's the difference between these two? One would be the wavelength, and the other would be the frequency. So very easy to do. Also, if you're very, very clever, the energy of a wave is given by E equals h times f, where h is Planck's constant. So an X-ray has more energy than a radio wave because it has a higher frequency. Just to be clear, this isn't on your syllabus. That's just another way you could have said there was a difference between those two. It is not on our syllabus. The graph shows 5 pulses of a signal from a pulsar. Explain how the graph shows the signal is not digital. It has more than 2 values, so it keeps going up in the value here, and then down, and then nothing, and then up in the value. Now, if this was a digital signal, we should just go straight up, and straight down, and across. So it just have that value, and then the off value. So a digital signal only has 2 values. This has more than 2, and we're going to refer to that shape to show that it does have a gradient, which it wouldn't have a gradient if it was an on and an off signal. And we're going to use the graph to estimate the time between each pulse. Now, I think what they've done, they've given you 2 values that you could have. I think one value that they've gone from the center of the pulse to the next center, and one value where they've gone from the edge of one to the edge of the other. So you get these 2 values, but we're going to use the graph to estimate the average time, so we need to take more than one value. So they would have expected to see you using lots of values and then doing an average of them. And then we're going to calculate the frequency of the pulses in the signal. We're going to use our equation, f equals 1 over t. We're going to pick the right one that we used here, the time here, and then we're going to use that to work out our frequency. If you used 1.15, we'd put it into this equation, and then we get the frequency of 0.87, and then the frequency would be measured in hertz for 2 marks. And that's question number 8.